Okay, gang, so here's another way to solve for population variance and population standard deviation using a different kind of formula. This formula is the computational formula. But like I said in the previous videos, it doesn't matter which one you use, whether you use the definitional formula or the computational formula, both of them will get you there. You know, both of them will solve the problem for you. It doesn't matter to me. So I just wanted to give you a couple options. Use whichever one you feel comfortable with. If you like the definitional formula, use it. If you like this one I'm about to show you more, then use this one. I prefer to use this one, the computational formula. I'm just faster at it. I feel like it's less time consuming, but it's up to you. Doesn't matter to me as long as you do them correctly, right? Because I want you to get the correct answers. So let me switch to my well, I guess first let me show you the formula on the PowerPoint, and then I'll switch over to my whiteboard screen so you can see that. So here's what we're going to do first for the formula for population variance. It looks like this, and this is like probably the first formula for this class where students tell me they feel intimidated, like just looking at the formula. There's almost like no numbers in there, right? So you think like, what kind of math is this? I see that some things are squared, but I don't see any other numbers at all. So but remember, we already went over like this notation the very beginning of this chapter. So this is the sum of the squared x's, and this is the squared sum of x. So those are pretty easy to calculate. And once we have those two numbers, n is just the total number of scores that we have. So that's easy to plug in. So let me show you how to walk through this formula here for the population variance, and then um, we'll talk about population standard deviation. We'll just do those on the same whiteboard over here. They're so simple to do. Okay, so let me switch back to my whiteboard camera, and we will calculate these. There we go. So these are the same numbers I used for the previous example when we went over the definitional formulas. So let's see if we get the same thing. We should get the same numbers. Let's find out if we do. All right, so here's how I like to solve this problem. I like to pick out all the information that I need to plug into the formula. I need to get the sum of the squared x's, I need the squared sum of x, and then n is really easy. And since n is really easy, let's just do that first. So this is the total number of scores. So we just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we got 10 scores there. Perfect, right? Now we want to get the sum of the squared x's, and we want to get the squared sum of x. So we need these three pieces of information here to plug into our formula. We got one down, two to go. So let's do this. The sum of the squared x's. Well, okay, well, to add up squared x's, we have to have some first. So let's just square let's square all of these values. So I'll get my calculator out. So make sure that makes me go a little slower. All right, so we know 10 squared, that's easy, do that in your head. All right, so let's plug those in for our 10s. Let's do 12 squared. So what's 12 times 12? And you guys probably have some of these memorized, right? 144. Okay, what is 15 squared? So 15 times 15 is 225. So plug those in there. 8 squared, I can do that in my head. That's 64. 17 squared, okay, now I'm getting a little out of my depth. So let's do 17 times 17. A little harder for me to do quickly in my head, but that gives us a 289. All right, what about 13? 13 times 13 is a 169. And 16 squared, 16 times 16 gives us a 256. And 17 we already did, and we know that comes out to 289. There we go. So now all of our numbers are squared. To get the sum of the squared x's, we simply add up this column here. Now that's a lot of numbers, most of them 3-digit numbers, so give me a sec. Let's get the calculator out. So we do 100 plus 144 plus 225 plus 225 plus another 100 plus 64 plus 289 plus 169 plus 256 plus 289 equals. Okay, so we get we add up all of these, we get 1,861. You see that? Okay, so that's just adding up this column. Now, to get the next number, we're going to start with the parentheses first, so we need to add up x. So to get the sum of x, we just add up all these x values. So that'll take a second, right? Let's do 10 plus 12 plus 15 plus 15 plus 10 plus 8 plus 17 plus 13 plus 16 plus 17 equals 133. Right, that's our sum of x. That's just adding up these numbers here. I remember that number. We got that the last time we did it in the definitional formula. So now to square that, right, to get the info we need, we just take 133 squared. So we're going to do 133 times 133 equals, it's a pretty big number, right? 17,689. So I'm going to copy that up here. 17,689. Cool. All right. Now, just to clean things up a little bit, I'm going to erase this work that we just did because we have the final product that we need up here, all three pieces of info for this formula. So now we can just plug them in and solve. So let's do first, make sure everything goes in its right place. We're going to do 1,861 subtract 17,689 over 10, and in our final denominator, 10 again. Voila, right? So let's do this step at a time. First thing we want to do is divide 17,689 by 10. So we got, oh, that's convenient, 17,689 divided by 10. And you could probably do this in your head because it's by 10. That makes it easy. So we get a 1,068.9. And then the final denominator is 10, right? All right, so we're breaking down this formula into steps. So now let's do the numerator. 1861 subtract 1768.9. So 1861 subtract 1768.9. Let me double check. 1768.9. Yeah. Okay, so we subtract across and we get 92.1. And then we're going to divide that by 10. So 92.1 divided by 10 gives us 9.21. So the population variance based on the computational formulas is 9.21. Is that the same thing we got when we did it the long way by hand? I believe it is, right? So you can see you can do this either way. Now the last step, now that we've got the population variance using the computational formula, now let's do the same thing, with the, erase this, we'll get the standard deviation. Okay, so the population standard deviation, and this was the goal, right? We want to get the standard deviation all along because it gives us the average distance from the center. There we go. So it looks like this, and we're going to put in the formula here. It's like a big square root symbol, and it's going to go over all the work that we just did, right? So it's going to look like this. But we already did all of this work. We don't need to do it again, right? We already did all of this, everything underneath this huge square root symbol. So you could just rewrite this. I'm going to leave this x off. We don't really need this x. That's just a placeholder. Like our variable name is x. All right, so we have the standard deviation equals the square root of the variance. All right, so for us, the variance was, what was it? I forgot. 9.21, right? Was 9.21. So we're going to do 9.21 and the square root equals 3.03. There you go. So the average distance from the average is 3.03. So the majority of scores, what we call a typical score, falls within plus and minus 3.03 of the average. And the average was 13.3. So the majority of scores are 13.3 plus or minus 3.03. That's where all the scores lie. Or, sorry, the majority of the scores, the typical scores. Cool, easy, right? So you can choose whichever one you want. You can use the definitional formula if you like that one more. You can use this method, which is the computational formula. Doesn't matter, it'll get you to the same destination. So I'll leave that up to you.